previously, we have learned about exponential functions. And this lesson serves as a bridge between the concept of exponential functions and the next concept that we're going to talk about in later lessons called logarithmic functions. And this lesson is a little bit of review from the chapter on functions, but there's a little bit of new material in this lesson as well. So a little review. We remember back from a previous chapter on how to find a composition of functions. So here we have two functions. F of x equals 3x minus 5, and g of x equals the square root of x. And if you're told to find f of 4, then all you do is you plug a 4 in for x and solve. So plug a 4 in for x into the f function, so we have 3 times 4 minus 5, which is going to be 7. If you're told to find g of 16, you plug a 16 in for x in the g function, and you have the square root of 16, which is going to be 4. And then you can combine those functions into something else. Maybe we have f of g of 4. So what we do with the composition of functions is we start on the innermost function and find the g of 4. So to find g of 4, I look at the g function and put a 4 in for x in the g function. So now I have g of 4 equals the square root of 4, which would be 2. So instead of g of 4, I can now put in this 2. So now instead of f of g of 4, I would have f of 2. And for f of 2, I plug a 2 in for x into the f function. So instead of f of x, I have f of 2. And instead of 3 times x minus 5, I have 3 times 2 minus 5, which would give me 1. So my solution for f of g of 4 would equal 1. Here's another example. We have two functions, and we're told to find g of f of 4. So we start with the innermost function, f of 4, and you plug a 4 in for x into the f function. So instead of f of x, we have f of 4, and instead of 3 times x minus 5, we have 3 times 4 minus 5. 3 times 4 minus 5 is equal to 7. So in place of f of 4, right here, I can put in this 7. So instead of g of f of 4, I will now have g of 7. G of 7 means I plug a 7 in for x into the g function. So instead of the square root of x, we have the square root of 7. So my solution for g of f of 4 would equal the square root of 7. Now we're going to do the same thing, but in general for two functions. So instead of plugging in something like an actual number into one of the functions, what I'm going to do is just try to find the composition of the two functions in general. Meaning we're going to find f of g of x instead of like f of g of 3 or 4. But what we do is the same process that we did with numbers, where we start with the innermost function and we put in here, instead of g of x, we put in the equivalent of g of x. So instead of g of x, we're going to plug in the square root of x, because those are the same thing. So instead of f of g of x, I can have f of the square root of x. And here, once you have the f of the square root of x, what I do is, looking at the f function, in place of x, I'm going to put in the square root of x. So here, instead of x, we're going to put in the square root of x. So my solution, f of g of x, would equal 3 times the square root of x minus 5. And we could go the other way, where we have the same functions, and we're told to find g of f of x. So the g function comes first, and then the f function inside of it. So same concept. We're going to start with the innermost function, and replace f of x with its equivalent. So instead of f of x, I'm going to plug in a 3x minus 5. So instead of g of f of x, I now have g of 3x minus 5. Which means that in place of x in the g function, I'm going to put in a 3x minus 5. So in place of x here, I'm going to put in a 3x minus 5. So what we have is the square root of 3x minus 5, and that is my solution for g of f of x. Now let's look at another example. And in this example, we are told to find g of 1 and f of g of 1. So to find g of 1, I plug a 1 in for x into the g function. So instead of 2x minus 4, I have 2 times 1 minus 4. So 2 times 1 minus 4 would give you a negative 2. Okay, and then f of g of 1. And then to find f of g of 1, what I can do is in place of g of 1 right here, I can now plug in this negative 2, because g of 1 is equal to negative 2. So what I have is f of negative 2, which means I plug a negative 2 in for x into the f function. So I now have a negative 2 plus 4 over 2, which would give me 1. Now let's take a moment and see what just happened. Okay, so we started with a 1. We plugged a 1 in. We got back out a negative 2. We plugged a 1 into the g function, got out a negative 2. Then we plugged the negative 2 into the f function, and we got back out a 1. Notice that the two functions undo each other. Right? I start with a 1, I get a negative 2, then I put a negative 2 in, get a 1. I'm right back to where I started. So the f function undoes the g function. So we would say that those are inverse functions. Just like addition and subtraction are inverse operations, because the addition would undo subtraction. If we added 4 and then subtracted 4, they would cancel each other out. Same idea here. These functions are undoing each other, so therefore they are what we call inverse functions. Okay? And so with that being said, the question would be, how do we know if a function undoes another function without having to go through, each of these different numbers? And it could just be coincidence, right? It could just be, in this case, the 1 and the negative 2 would undo each other. So we want a way to show that two functions are indeed inverse functions. So to do that, looking at the same two functions, what we do is we use the composition of functions to determine if two functions are inverses. So here, for example, we need to find f of g of x and g of f of x. Okay, so we start with f of g of x. Remember, we start by plugging in the g of x equivalent, so 2x minus 4, in place of this g of x. So instead of f of g of x, what we have is f of 2x minus 4. And what that means now is that, looking at the f function, we're going to plug in a 2x minus 4 in place of x right up here in the f function. So what we have is going to be 2x minus 4 plus 4 over 2. Well, 2x minus 4 plus 4 to give you, those would cancel. So I have just 2x over 2. And 2x over 2 you can divide and get 1x remaining. So f of g of x, the composition of those two functions, equals x. And now let's do the same thing for g of f of x. So for g of f of x, what we need to do is we need to plug in f of x, or x plus 4 over 2, in place of the f of x right here. We are substituting the x plus 4 over 2 in place of the f of x. So instead of g of f of x, we have g of x plus 4 over 2. And then from here, what we do is, looking now at the g function, in place of x, we're going to plug in x plus 4 over 2. So right here, instead of x, we're going to put in this whole thing of x plus 4 over 2. So now we have 2 times x plus 4 over 2. 2 and then over 2 would cancel. You're left with x plus 4. And don't forget the minus 4 out here at the end. So we have x plus 4 minus 4, which would give me just x. So notice for f of g of x and g of f of x, both ways, our solution is equal to x. And that is the way that we can determine if two functions are inverse functions, is we find the composition both ways of g of f of x and f of g of x, and if both equal x, then the two functions are inverse functions. So we see here algebraically how to determine if two functions are inverses. And then graphically, what we have is right here, where a function's inverse is reflected across the line y equals x. So the red line is the first function, x plus 4 over 2. And then the blue line, or purple, is your other function, g of x, there's a g of x, equals 2x minus 4. And the black line in the middle is y equals x. And notice that the red line is reflected across the black line, the y equals x. So graphically, that's what we have, is where the two graphs are reflected across this y equals x line. Now the question is, how do we find an inverse function? So if you're just given one function and not the other, how do we determine what the inverse function is? Well, here's a function given to us. F of x equals x to the third power plus 1. And our goal is to find the inverse function, which, by the way, this is your inverse function notation. With a little -1 above the f, that means inverse function. It does not mean you're raising it to the negative first power. Okay, so take note of that. But to find the inverse function, what we do is, first thing is, we can think of f of x as y. So we have y equals x to the third plus 1. And then we want to switch the x's and the y's, and then solve for y. So here in place of the y, I'm going to put an x instead. And here instead of an x, I'm going to put a y. So what I have is x equals y to the third power plus 1. So we just switch the x's and the y's, and then we're going to solve for y. So to get y by itself, I need to subtract 1 from both sides, which leaves me with y to the third equals x minus 1. And then I need to take the cube root of both sides to get rid of the cube. The cube and the cube root will undo each other. So I take the cube root of both sides, and now I have y equals the cube root of x minus 1. And we're done. We've solved, and we found the inverse function. But take note that the notation we use for the inverse function is right here, and we can replace the y with that notation. So what we have is f of -1 of x equals the cube root of x minus 1. And that would be your solution. Now, this entire lesson up to this point has been to build to the fact that we have an inverse of exponential functions, which we discussed in the last 2 lessons. Here, an exponential function you see graphed, and a logarithmic function is the inverse of an exponential function. And we'll discuss logarithmic functions in more detail in the following lessons. But remember, we said that inverse functions will be reflected across the line y equals x. So here we have y equals 2x, and if you were to graph the line y equals x right here, and then reflect the exponential function across that line, we're going to have the inverse function, which is what we call a logarithmic function. So here we have the function y equals 2 to the x power. The base is a 2. So we say this is an exponential function with a base of 2. Over here, the inverse function, we say that this is a logarithmic function with a base of 2. And this 2 is a subscript, by the way. It is kind of smaller and below the regular font. And then the x is also regular size. So the 2 is beneath the log in the x. So how we would say this in English would be log base 2 of x. In the following lessons, we will get into more detail on how to work with logarithms and how to solve with logarithms and all sorts of different things with logarithms. And that concludes our lesson for today. We will see you next time.